Hello guys and girls, this is Lekshman MJ. Welcome more of you to Global Coding Cohort. If you are a new viewer and if you don't know Python language, then you may watch session 1, session 2 to session 15. And in these sessions, I have explained basic Python and you can learn basics from there. In this session, we are going to solve a small coding problem. And if you have any problem statements available with you, you can submit those questions through the Google form link, which I have given in the description of this live. You can click on that link and upload your problem statements along with at least two sample input and output. If there is any issue in audio or video, please let me know in the comments. Okay. Uh, the code files that we will be that we use in this live session will be uploaded to my GitHub repository. The link to my GitHub repository is given in the description of this live. Let's get started. Make sure to like and subscribe to this channel. Please support us by sharing a few words about this community to your colleagues. Today we are going to solve a problem. The problem is to check whether a given number is prime or not. And let's start the coding problem first. This is the problem statement. Okay. Check if the given input integer n is prime or not using Python. This is a statement where constraints, okay, or constraints. One less than n less than 100. Sample print. Enter n uh, 3 sample input 1. Okay, input 1. Sample input 1. 3 is prime. Sample input 2. Twenty-four is a prime number. This should be the output. So we have constraints, the question constraints, the two sample input and outputs. So this is the problem statement. Our task is to check whether the given input number n is a prime number or not, and n ranges from, the input can range from 2 to 99. Just for example, I have taken this range. Okay, this is the constraint. Input can be between, input should be between 2 to 99. So sample input 1. When sample input 1, n is 3, isn't? So at that time, it has written that 3 is a prime number. 3 is a prime number. So what is a prime number? If 3 is a prime number, then what condition is defining this is prime number and this is not prime number? What's differentiating the numbers as prime and not a prime? The prime number, any number that is divisible to that particular number. For example, in our case, this is 3, right? 3 is divisible in 3 table. 3 is divisible in 3 table. 3 is divisible in 1 table. Then second input is 24, is divisible in 1 table, divisible in 2 table, divisible in 3 table. So it keeps, the difference is, if a number, it is also divisible in 24th table also. Okay, it is also divisible in 24th table also. So the condition that differentiates the numbers as prime and not as a prime number is, if a number is just divisible only by itself. Here in this case, in this first scenario, this number is divisible by itself. Itself means it's divisible by 3, and it is just divisible by 1, because 3 goes to 1 table also, isn't it? Here you can see in this multiplication table, 3 goes to 3 table and as well as to 1 table. Those numbers which only goes to one table and to itself is called prime number. And to itself means, as this is 3, 3 goes only to 3 table and to 1 table. So this is prime number. If it goes to any other table, then if it goes means if it is divisible by any other table, then that is not a prime number. It should be divisible only by itself and 1. Understood? It should be divisible only by itself. Itself means here in our case 3. 3 means 3 and 1 table. So that those numbers are called prime number. For example, let's take 4. 4 4 goes to 4 is divisible by 4 table. 4 is divisible in 1 table, but 4 is also divisible by in 2 table. So this is not prime number. But whereas in case of 3, it is just divisible by itself. 3 table just goes to its own table and 1 table. It is just divisible by its own table and 1 table. But whereas in case of 4, it is divisible by itself. It is divisible in 1 table. It is also divisible in 2 table. So it is not prime. 4 is not a prime number. I hope you understood. So this is what the math behind this prime number concept. Now our task is to write a Python code that checks if a number is prime or not. So in general itself, in manual mode itself, what are we doing? When we get 3, we are checking whether by default all number will go to its own table and 1 table, is it? By default, any number goes to itself and is divisible by its own table and 1 table, isn't? Do you agree or not? Any number is divisible by its own table and 1 table. Understood? But if it is divisible by any other table, in case of 3, other table means 2, 4, 5, 6, etc., etc. Understood? If it is 4, other tables means uh, except 1 and 4 are 2, 3, 2, 3, 5, 6 are other table for 4. Because by default 4 and 2, it is divisible by itself. 4 is divisible by itself in its own table and 1 table. So other table means for 4, other table means 2, 3, 5, etc., etc. For in case of 3, other table means 2, 4, 5, 6, etc. Clear? So just in, just no, we need not think in a programming way. Just in a manual mode itself, what are we doing? We are going to check the other table if this goes to other tables. Isn't it? So the same way, let's try to implement it here. But there is a condition. Other table means you can have 100 to table, 1000 to table. Uh, Likewise, you can go on, isn't? Go on checking. But at some point of time, you should stop, right? And we need certain analysis to be done to stop it at some point of number, isn't? So what inference can we get from this? Okay, let's take the same example 3. In case of 3, what I can see is maximum the number will get divisible by is its own table. That means if it is 3, we need not check in 4 table, 5 table, 6 table. Analysis. We need not check. Or else you can write enough to check No problem. You need not check from n plus 1th table multiplication 3. This is one analysis. That means, so a maximum we will go till 3. Got it? And next thing, as we know, any number is divisible by itself and 1. It is enough to analysis to first analysis. Let's write like this. Any number is divisible in its own table and one table. So after that only we are coming to the second point, isn't it? Okay. Now, okay, this is also this will also work, but think about its time complexity of this algorithm. We will just keep checking till n, isn't? There is no need actually. How? I can come up with another one more analysis itself. Not just not with these three. I will take another example. Okay. Which example can I take? Okay, in case of 4, let's take the 4. In case of 4, when n is 4, I know it will do it will get it it is divisible by itself and 1. Okay. In the second analysis, we plan to stop by this place, but uh, because the time complexity of this algorithm is n, we are trying to find a different way. If there is any different alternative way, so that we need not check all these 2 and 3 in between. In case of, so for, this is the case of 4. Okay. In case of 99, will you keep checking till 2 table, 3 table, 4 table, 5 table, 6 table, etc. till 99th table? We cannot write. That's why. So in this small example, as 10 is 4, we need not check 2, 3, and 4. 4 and 1 we will not check by default. Okay, 2 and 3. We are finding a way. If we can just try to understand, try to get the what we expect with a half of not at first we will not understand, we will not know whether it is half or 3/4. Okay, so what analysis I go to get, what observation I can do over here is, if when it is 4 in half a table, for 4 half is 2 isn't, half of 4 is 2. So in n divided by 2 table, n means 4, 4 divided by 2 is 2, and in second table, in 2 table itself, you can get that number in 2 into multiplication of n by 2 table. So can we put a bracket now here? That means in a place, based on second analysis, we stop in this n, and then our third analysis is this. If a number is going to be divisible by any other table, obviously then we can find it just by checking till n by 2 table. In case of 4, we will check till 2. Okay, for example, if it is 6, then we will not check 2, 3, 4, 5. We will not check all these 4 table. It is enough to check in case of 6, when n is 6, it is enough to check till 3. Till 3 table. Understood? We need not check 4 and 5. So we are in 2 step itself, we can find the answer to it. In case of 6, in 3 itself, it is present. So we can declare it as non-prime number. Understood? If something goes, then we can Okay, I will try to show you. Based on our based on first analysis, we told by default any number will go to will be divisible by itself and 1. Based on second analysis, we put a bracket to from to check from truth table to n minus 1 table, and based on third analysis, we are again going to reduce the number of steps in finding whether that is prime or not. So to n by 2 table. If something will be divisible, we can find it within this range itself. Now, okay, let's how up to 3. If some if n is not prime, then we can identify it within n by 2 table. 2 to n by 2 table. The reason is why why we came up with that analysis. You understood, right? 6 means you can find the 6 in 3 into 2 itself, in third table itself. Then why should you unwantedly check 4 and 5? Understood? If something is not prime, you can find it in this table itself, n by 2 itself. And first I will write code for based on this 3 analysis. After that, I will optimize it again. Okay, and I will show you another one more analysis. But first, let's have something like this. Let's write. Okay. In range 2 to 1 by 2. Second, sorry, we have to check this out. If n is okay, divisible means how we understand is mod operation. We will use mod operation. When we do mod operation, I will show an example also. For in case of 3, when 3 is divisible by 3, then 1 3 is 3, we have 0 in the remainder, isn't it? But in case if it is not divisible to that number, then we will have, for example, 3 divided by 2. In this case, 1 2 is 2, we have 1 as a remainder. Mod operation stops with the remainder. It will not put additional and proceed. It will just stop over here. Understood? So we have a non-zero number as a remainder. When we get non-zero number as a remainder, then it means then that this particular number is not divisible in 2 table. Whereas in this 3 is divisible in 3 table, so we got 0 over here. Understood? So we are going to write n divisible by I. What is coming in I? I means each table, okay? Let's give a name for each table. Each table. If it is equal to 0, let us have a flag. Okay, flag as a variable. If something is equal to 0, this flag will be turning to 1. Or let's have it as false. have it as true. No problem. If it is equal to 0, then we will change the flag to false. That means we will say that is the number is getting divisible by that table. So if flag is false, then we will print n is not the prime number. Else we'll print the same line itself because we just have only one line over there. N is a prime number. If we just have one line, I'm going to show that to single line. Understood? So now let's simply have n over here. Let's give 3. Let's see. N is a prime number. Showing n is a prime number. Why did that happen? N divided by 2. Oh, oh, this is too. This is very small number. Okay, we have to maintain that. We have to put some check over here because if it is 6, it will work. But in case of 3, this cannot work because n divided by 2 is becoming 1. Means halfway, half or mid number. Let's give it as mid number. Mid equal to if we have to do this operation only if mid is uh, greater than 2. Sorry, greater than 1. Only then we should proceed here. Otherwise, we should not proceed with this for loop. Then mid. So in case if we are not proceeding forward, how to identify when in case of 3, how to identify? We have to write an else part. What is the other number that is present for? Mm, oh, sorry, no problem. We can adjust it there itself without this. If itself we can adjust it just by giving +1. Because a range will generate. If we give 5, then it will generate till 4, isn't it? When we give 2, then it will generate till 1. When we give 3, it will generate till. Okay. So in this case, uh, range of 2 to 2 will generate 2. So this loop will run for one time. Is this running for one time? Let's check. It's stable. It's not running. Okay. 2, comma. Oh, we are getting okay. 2 in this is okay. Okay. In mid we have we are getting 1. So 1 plus 1, it's becoming 2. As we are starting from 2, this loop will not run. So in this case, what can we do? Okay, let's put n plus 2. Let's make it work. Okay. We will optimize the code by running this on by each time, each table. We can use print okay to understand how this code is running. Okay, now it's loop is running, and something we have to fix over here. We understood that if it is not divisible by 0, if it is divisible by 0, it is not a prime number. Not a prime number. If true, it's not a prime. If true, it's a prime number. In our case, what's happening? What's happening in this place? Let's print that also. Let's print that also over here and check. So we're getting 1. If you are getting 1, else flag is already true, so we may not rewrite it. Okay. So the flag will not become false. If flag equal to true, it will remain true. If it is remaining true, our prime 3 is a prime number. Okay, 3 is already a prime number. Yeah, correct. 3 is already a prime number. So okay, code is working fine. Now let's try for 4. 4 is not a prime number. Get it? 4. Okay, let's give 5. 5, is it a prime number? 5 is not a prime number. But our Rosen, we are getting 5 is a prime number, isn't it? So what would have gone wrong? So we can write a condition over here. If if n is greater than 5, then we can have mid as this one. Else we are updating the variable to n plus 1. Is 5 a prime number? It is divisible by itself and 1. Okay, already it's right. No problem. I just got confused here. No problem, no problem. 5 is a prime number, isn't it? 5 is a prime number. So I got confused. 5 is a prime number, so it's working correct. Let's give 6. What's happening? 6 is not a prime number, right? Let's give 11. 11 is a prime number because it's divisible by itself and 1. Okay, correct. What's our second scenario? 24, isn't it? Let's check for that. So 24. So is our looping running till 24? Oh, not 24, till 13. Okay, okay. It is running till 13. Okay, that's fine. No problem. But why did we put 2 over here? Because in case of 3, we want this loop to run, isn't it? Okay, what if we give 2? Our condition is we can give 2 to 99, isn't it? What if we give 2? By default, as we are giving flag equal to true, that means anything, even if we give 2, Though we start over here, our loop will not run. But by default, we are giving our flag as true, isn't? So that's why in this if condition, it will work correct. Though this loop will not run, by default, we are giving a flag as true, isn't? Okay, let's rename the flag to prime. Why should we keep a non-meaningful word? Let's keep a meaningful variable, prime. By default, we are telling it's a prime. Sorry, not prime. Uh, by default, let's have the variable not prime. Not prime is true. Not prime becomes false. It's not prime. But in case of 2, 2 is a prime number, isn't it? Is 2 a prime number? Prime numbers. Let's confirm it. Prime numbers. 2, 3, 5, 7. 2 is also a prime number. So we should not get it as a, because 2 will go for itself and for 1. So we should not get this, isn't it? So we have to manage something here. Uh, not prime. Okay, let's have a condition something like this. Uh, else n else n less than, only if it is false it will come here, right? Isn't? So whenever not prime is true, it will come to the next condition. So let's give a condition over here. When something is, or no problem, only 2 is getting accepted, right? Let's give 2 over here and print 2 is a prime number, because only 2 is accepted. Obviously, we will not give 1 because our input is, we have a condition which should give only the numbers between 2 to 99. Only 2 is accepted. Is this working? Let's check it now. Not prime, is it correct? Prime will do. Not prime will confuse. Prime will do. Because I'm trying to give a meaningful variable name. That's why. Okay. Prime will do. Okay. Now let's check. Variable is updated everywhere, right? Okay, fine. 2 is a prime number. If n not equal to 2. Here also we have to accept that. This loop should not run. But this should run for other numbers. That's why we are accepting just 2. When we give bigger numbers, this should work. Okay, now let's check 4. 4 is not a prime. 5 is a prime. 6 not a prime, right? 7, 7 is a prime because it goes just for 7 and 1. Okay, 8, let's check. It's not a prime. 9, it's not a prime. 10, it's not a prime. Okay, fine. Now this is correct. So our code is working perfectly. But now let's check the time complexity of our code. What's the time complexity of a code? The time complexity is around n by when it is 3, it's fine till okay, let's reduce one more thing. If n greater than 3, then we can just use this. It's n greater than 3, then we can just use something like this. If let's see, and let's remove +2 from here. Okay, for 3 is 3, it's executing. For 2, correctly executing. For 4, we want it executed till 2. Okay, it's also right. Okay, now for 6, it should check till 3. Okay, okay, it's checking till 3. Okay, fine. It's working right? The time complexity of code is currently n by 2. Time complexity of above code is time complexity of above code is O of n by 2. Okay, this code is working, but let's check if we have any other possibility to reduce even further. We have to reduce the time complexity as much as possible. Is okay, as minimum as possible. Let's check if there is a way. Mm, one more analysis I am going to tell you right now. That means uh, let's take some number. Let's take 100. 100 goes to 10. This is divisible by 5 table also. This is divisible by 2 table also. So 100, this is divisible by 5 also. This is divisible by 2 also. Okay, let's take 7 table. The elements in 7 table, 7, it's a prime number. Okay. 14, it is divisible by 2 table also. 21 is divisible by 3 table also. 70 is divisible by 5 table also. Got it? In case of 16, 8 is divisible in 2, 16 is divisible in 2, it is also divisible in 4, 24 is divisible in 3, 32, where? 32 in 4 table also. So likewise, even if we check this, those numbers that are divisible in higher numbers are also getting divisible in smaller tables also. So my observation in this way is it is enough just to check 2, 3 and 5. Understood? It is enough just to check 2, 3 and 5. analysis. Extended analysis. Fourth way as numbers divisible in table greater than 5 are also divisible in any of the table, any of uh, any of any one of the table, any one of the okay, not on any one, in either 2 or 3 or 5 table, we can just get it identified by checking these three tables, these three tables, table itself. So based on this fourth analysis, n equal to 3 if n not in, we have to accept these three reasons. 2, 3 and 5 we know are already prime numbers. Beyond this, else for friend n the prime number. In this case, if n mod if n mod 2 equal to 0, or if any is divisible, if the number is divisible to any of these three tables, 2, 3 and 5, then that is not a prime number. That is our analysis. 3 equal to 0, n mod 5 equal to 0. If the given n is divisible to any of these three tables, then that number is not a prime number. It's not a prime number. Else, friend n is a prime number. So now, what is the time complexity of this present code? No, because before that, let's check with different numbers. Okay, 3 is a prime number, 2 is a prime number, 4 should not be a prime number, 5 is a prime number, 6 is not, 7 prime, 8 not prime. So it's working perfectly for different outputs. Sorry, for different inputs. 24 is not a prime number, 99 is not a prime number, 90 is not a prime number, 91 is a prime number, and things are working correctly, isn't it? So let's check the time complexity of this particular code. The time complexity of the above code is, any guess? If you have any guess, please let me know in the comments. Complexity of the above code is, any guess? Of Is there any loop? No, isn't. So 1. So which is having the minimum time complexity? Our second code, is it? So we will choose the latest algorithm, final. Therefore, we choose our latest. We choose our latest, or let's choose the code. Otherwise, uh, we choose our latest code as final code because it is having minimum time or minimum or best. Okay, okay. Ours have minimum small time complex minimum the bracket best time complexity. So this is our final code. Best solution. Our best solution is this. So in this case, you can get now input of and return various check various numbers. Okay, 88 is not a prime number. Understood? How we chose this specific code as a best one based on the time complexity. Okay, there is no loop at all. Based if you see the say we also have another possibility. If we just stop, if we do not think, just assume that we do not think beyond the second analysis. So what will happen means our time we will our code's time complexity will be O of n, which is even worse than our first code. This our first code itself is having just n by 2. If we did not think beyond this two analysis, then probably our time complexity is going to be O of n, which is bad. When there is a possibility, when we choose O of n, then that is a bad uh, way of coding, isn't? That is not a, that is an unfair way of coding. It may work. Its logic may be correct. It may be working. It may be checking correctly whether the number is prime or not. But in competitive coding, what is also important, we should try to come up with a best solution based on time and auxiliary space. In this case, we are not considering that because n is going to be constant and it's not growing anyway, isn't it? Here in this case also, we have not used any data structures, so it is not growing. The memory usage is going to be limited. Limited means constant. Okay, constant is the correct word, not limited. Okay, memory usage is going to be constant because once this is okay, it is going to be constant. Whatever, irrespective of the input that you pass, the memory usage of this particular algorithm is going to be constant. So here we have just focused only on time complexity of these algorithms. We had 3 solutions, but we have written only 2 because if we stop just by 2, we will have another one more algorithm which is of time complexity of 1. What is your requirement? We should come up with a best solution. So finally, our last algorithm is having O of 1. So we have chosen that as our best solution. Understood? So if anyone have any doubt, please let me know in the comments. Type Q&A, or if you have doubt, okay, just type doubt. Just type doubt in the comments so that I will understand that somebody have doubt and will start a Telegram meeting. You can talk to me directly and clear all your doubts. As we are now standing in initial stages of these sessions, I'm explaining you even this small concept for 1 hour. While we move ahead, while we see some complicated problems, I'll not be explaining this deeply like I explained today. Okay, I can finish this. I can finish this coding in just even in less than a few 2 to 3 minutes. But I explained this much because I want to show you how the thinking process is happening, so that you can mimic and understand. You can think in this way, how to break down things, how to break down the things and think to form a solution. Just to show you those the thinking way, I explained this small tiny problem statement this deeply for 1 hour. Got it? As we move ahead, we will not see, we will not focus on small things. Those things you will have to understand. Those complex things I will be explaining in those complex problem statements. Okay. To make this session as a beginner friendly one, I have explained this tiny concept for 1 hour. You should not expect me to explain in this way while we move ahead day by day. Okay. Okay. And that difficulty level of the question will also keep increasing in every session. Only for first few days you will be seeing some tiny problem statements. Okay. We will keep increasing the difficulty level. Only then we can improve ourselves, isn't it? So I consider that no one has any doubt. Okay, that's it for today, folks. Go through the code, understand why we wrote certain line. Go through the even you can find this video saved in the live section of my channel. You can watch it again and again and go through and understand and grab the thinking process that we went through. Okay. Okay. See you with another problem statement tomorrow. So that's it for today. Bye bye.